Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will graph y equals tan x and we'll look at the role of asymptotes. So for the graph of y equals tan x, remember tan x is the same as sin x over cos x. And that identity there has a huge role to play in the graph of y equals tan x. So because it's sin x divided by cos x, at every point where cos x equals 0, tan x is undefined because you can't divide by 0. So we know from previous graphs and from exact values that cos x is equal to 0 when x is equal to 90 degrees or 270 degrees and so on. There are many more. So for y equals tan x, x cannot equal 90 or 270 degrees. So these lines, x equals 90 and x equals 270 degrees, they are asymptotes for the graph y equals tan x. So those green lines constitute no-go zones for the graph. It cannot hit those green lines. So we also note from the unit circle that tan of an angle is the same as tan of 180 plus that angle. So like tan of 10 degrees is the same as tan of 190 degrees. We know that tan of 45 degrees is equal to 1 from our exact values. So if I add 180 to that, I get 225. Tan of 225 degrees is also equal to 1. But what this also means is that the asymptotes won't just be at 90 and 270, they will keep going at every time we add 180, or even if we subtract 180. So there'll be asymptotes at minus 90, 90, 270, 450, there'd be one at 630 if we went on like that. We note that tan of 0 is 0. So the tan graph will go through this point here. This also means, of course, because tan of theta equals tan of 180 minus theta, so tan of 180 will be 0, and tan of 360 will be 0. So what actually happens, because tan can take any values except all these at the asymptotes, the graph will be in heaps of pieces. It actually looks like this. So the graph, as I said, is in heaps of different pieces. This one, this one, this one. There'd be another piece over here. They all look exactly the same, like this. So what's different about the tan graph and the sine and cos graph? Well, there's heaps different. You know, the sine and cos graphs went up and down like this. They didn't have asymptotes, whereas the tan graph does. Another very important difference is that, remember, the sine and cos graphs just by themselves lived between 1 and minus 1. They would have a maximum at 1 and they go to the minimum of minus 1. They'd sort of keep oscillating between the minimum and the maximum. See, y equals tan x doesn't have a minimum or a maximum. It just keeps going to negative infinity down all these lines, and it goes to positive infinity on all those lines. So that makes sense if we go back to our normal SOHCAHTOA, right back to the start of trigonometry and right-angled triangles. So remember that sine was the opposite over the hypotenuse. The hypotenuse is the longer side. The opposite has to be less than the hypotenuse. So the opposite divided by the hypotenuse is always less than or equal to 1. That was the same for cos. But for tan, remember, is the opposite over the adjacent. The opposite can be longer than the adjacent. The adjacent can't be longer than the hypotenuse, but the opposite can be longer than the adjacent. That's why tan can take any value, why tan can be more than 1, but sine and cos cannot be more than 1. So it is a weird graph, and you've probably seen nothing like it in the past, but I know you can handle it. Remember, it's just in lots of different pieces. Tan can take any value. It goes from minus infinity to positive infinity. It has asymptotes at minus 90, 90, 270, 450, and so on every time we add or subtract 180. And at multiples of 180, it hits the x-axis. So at 0, 180, 360, at 540. Other than that, it sort of looks a bit like a cubic. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.